And now I would like to introduce John Cantle from New Instruments, who's come to join us from the UK, and we're delighted to have you with us. So,
John Williams had also planned to be here. He's the top man, the boss at New. Unfortunately, he had an accident in his garden, so he sends his apologies. New Instruments wasn't around then, but of course the people were. We were doing different things then. John was a postdoc student at London University, actively working with Alan Gray, developing and improving the quadrupole ICP-MS technique. I was involved at VG, running the quadrupole division in Winsford. So we were around doing slightly. It turns out that the lifetime of JAAS, roughly speaking, corresponds with the commercial availability of the technique. And so it's not surprising that ICP-MS features very strongly in the publication. And one of the publications, one of the first ones that we found in the journal for ICP-MS is the Plymouth group here, Les Ebden, and this one here by Alan Gray himself. So these were some of the early publications that got into JAAS, showing the importance of the publication to the early work that was going on in these research departments. However, it turns out that possibly the real beginnings go back even more than a decade before that. And we were able to get hold of one of Alan's notebooks, and on one of the pages in very spidery writing, you can see what certainly looks like a sample introduction system into some form of plasma, some form of interface, and certainly a quadrupole mass spectrometer. This was work done when Alan Gray worked for ARL, Applied Research Laboratories, a very famous spectrometry maker back then, that isn't around these days. But it does show you that the true commercial availability of the technology occurred quite a long time after some of the early ideas. There were sketches unbelievably like what the commercial instrument turned out to be. However, it's probably true to say that in true scientific collaborative spirit, the technique that we now know as ICP-MS didn't come about until the marriage of two independent researchers put their heads together. And I remember well when Alan went over to Ames, sat with Sam, who was an ICP expert, and with Alan's background in mass spectrometry and general plasma, once the two got together, then, well, we know the result. And it resulted very quickly in a commercial product that I was very much involved in Winsford, the Plasma Quad 1. And in parallel, in Toronto, SciEx and Don Douglas were developing the ELAN. And for a number of years, these two suppliers were introducing the trace metal analyst to ICP-MS technology. And it's interesting, looking back then, what we thought was important. And it's probably true to say that not many of those issues have changed. We can still consider that having a wide range of elements being determined with low detection limit is important, because the alternative in those days was the single element technique of graphite furnace-ing. That's what a lot of people were used to using, and the ICP-MS had the potential of a true multi-element technique. Of course, automation, multi-element, high dynamic range, again because of the limited dynamic range available in atomic absorption. ICP-MS had the potential for, well, 6 orders and now significantly more. And lots of discussion on interferences, early opinions about interference freedom were subsequently, I think, called into question. But anyway, compared with emission technology, certainly the mass spec offered better backgrounds and freedom from interferences. And these are some of the data that I collected in the early days, just showing the commercial appearance of the technique at one particular trade show in the United States. It happens to be one of the largest internationally, but certainly might not include all of the developments that might have been occurring in Asia if those products didn't appear at PitCon. So here you can see the early SciEx product first appearing in 1983, and then the two machines in New Orleans in 1984. And you can see what I mean. For a reasonable period of time, there were just the two suppliers. And then, as you might expect, a lot of companies jumped in significantly. The introduction of the HP coming in after the development, the tie-up with Yokogawa in Japan produced a major change. But it's probably true to say that after that was a period of consolidation, and probably, if I continued this graph, it may well have started to drop after a while. But what didn't drop, of course, was the sensitivity. We've already had some discussion about sensitivity, and as you might expect, sensitivity increased from the early beginnings, and that's possibly could continue. These things depend on market forces. The manufacturers tend to respond to requirements from the user base. So now, how can we summarize the quadrupole technology? 4 major suppliers with factories in Germany, Bremen, Japan, where the Agilent product is made, Canada, where the Elan is made, and Australia, where the Varian Bruker product. It's looked upon as a black box. It's for making routine elemental analysis at levels that couldn't have been imagined 25 years ago, I think it's true to say. Now, what about magnetic products? Because now, putting my new instruments hat on, the magnetic technology is what we're more concerned about, because we don't make a quadrupole instrument. But what probably isn't generally realized is how quickly the sector developments followed on from the early quadrupole work, with the ICP coupled to a magnetic machine and then to a true multi-Faraday system. And once again, JAAS was there to help those early pioneers get their message across the scientific community. Here is Neil Bradshaw's landmark publication with Eddie Hall and Neil Sanderson with the Plasma Trace 1. This was an ICP coupled to a high-resolution organic mass spectrometer, and it became the Plasma Trace 1. And then a few years later, once again, the landmark publication in JAAS, Andy Walder, and here's a name that you'll recognize, Phil Friedman, who was the then technical director at Beijing, and is now, of course, the owner of New Instruments. This is a photograph of the first magnetic sector ICP-MS being installed in Tsukuba in Japan. You can see it's large, it's ungainly. You almost needed an octopus to control all of the electronics, but it enabled analyses to be made at in the circumstances that weren't possible before. So what was the driving force for sector-based ICP-MS? Well, probably, of course, the potential of higher sensitivity, higher transmission through a magnetic sector, and lower background compared with what the quadrupole systems were offering at the time. Separation of interferences, because you could spectrally resolve interfering peaks, and isotope ratios. It's probably true to say that that wasn't very far up the list in the early days, but it became more and more important, and you can see why. Sector sensitivity actually started lower, according to my information, when it was introduced, but rapidly overtook the quadrupole devices, and of course will continue to grow for as long as there are applications that require it. And you saw an example of that in the last talk. Now, this slide has a lot of information. I apologize that there is so much shown here, but in summary, the take-home message is that after a period of time where a number of manufacturers were involved in sector instruments, these days it's broken down almost to two colors. So sector-based ICP-MS with an ICP source is essentially available now from just two places in the world. That is blue for new plasma, for new instruments, and red for the Thermo factory, the original Finnegan factory in Bremen. So once again, as we saw with the quadrupole system, there was a period of growth where a number of different makers offered their version, but you can see through a number of changes and corporate rearrangements, those have fallen by the waysides, and we're down back to two. So new instruments came along during the period of time that we're talking about. It was founded in 1995, and the rationale was it occurred during a time when there was, I would say, some instability in the instrumentation supply situation. And two very clever people got together, Phil Friedman, who really invented the union of the plasma with the isotope ratio mass spectrometer while he was at BG, and Keith Irons, who was then a professor at a UK university, who needed this kind of technology. So between the two of them, they came up with an ICP mass spectrometer with a multiple collector where nothing moved in the collector except the ions. The collector configuration was fixed using a very innovative zoom lens arrangement. And because the origins of this company were small, without huge infrastructural service and support around the world, the design would be built really from the drawing board with high reliability in mind. And I think our users here in China would support that those issues were got correctly. Of course, like all the other companies, there's been growth during the period we're talking about, and now from its origins in ICP multi-collector, other types of mass spectrometers have been added. So the new atom, and the PowerPoint has slightly changed my bullet dots here. The new atom is the equivalent of the element product from Thermo. This is a single collector mass spectrometer with a vertical geometry using an ICP source and a double focusing high resolution detector, a range of stable isotope instruments for carbon-13, nitrogen, oxygen, hydrogen, etc. in gas form, instrumentation for measuring the noble gases, and then more recently a true replacement for the VG 9000 glow discharge magnetic mass spectrometer. And because we are always welcoming overseas scientists to our factory, and we receive visitors from China regularly, you'll need to know how to find us. And New Instruments is located in a place called Wrexham. It's not far from Manchester. If you're planning to visit England and if you have time in your schedule, please let us know, and we'll make you feel very welcome in this Britain. As a brief summary, what have we seen? We've seen the importance of clever scientists working together to gel their ideas, and we've seen a number of examples of that, specifically when how can Gray come together. We've seen how instruments grow, vendors into the market, and then consolidate. That will increase. And one other prediction I would like to make is that ICP-MS will become more and more a detector for other technologies. People will want to separate their samples and then do compound-specific metals or isotopes. So we have come far. I've not really attempted to answer the question. We've come a long way. Where will we be in 3 decades more? Maybe in this room celebrating that. I hope I'll be able to join you. And so thanks for your attention.